So right now we are into free fall.
Yeah. Oh, you wrote.
Same way in free fall motion also. It is positive acceleration.
Yeah, when it goes down, but
Deceleration.
Because it's against gravity.
Yes, against gravity. So it is retardation.
Yeah.
Negative acceleration while you go up in against gravity. Simple numerical could be asked on G, and it may involve h is equal to half. This is the time acceleration in both the
downward would be acceleration and upward would be
deceleration. The diagram shows the velocity of the ball every second as it rises to its highest point and then falls back to where it started.
Is it always pakka that if it starts at 30 it will end back with 30? It is pakka na? Or can it end back with like a 25 or a 45?
No, it is pakka.
So if it goes up by 30 it will come back and reach 30.
While going upward, then also it is minus g. While it is going down, then also it is plus g. Same value of acceleration, same height, then final speed also
same.
At 1 second or at 2 seconds. How will you get these speeds? We could apply directly. V is equal to u minus gt. U could be taken as 0. Initial was 30.
So it will be 20 then.
30 minus 10, that means 20.
This question is about the three.
Assume G is equal to 10 and that there is no air resistance. Okay. Stone is brought from rest. What is its speed after 1 second, after 2 seconds, after 5 seconds? Because during free fall, I must mention. So rightly you took. Correct.
This one is interesting.
This question is about the 3 points A, B, C
of this graph. In which direction is the ball moving at point C? Downward. At which point is the ball stationary? B.
In which direction is the ball moving at point C? Okay, this is final point.
Yeah, so I said downward. For stationary, I said point B.
Initially, motion started from point A.
Yeah, I think so. Because then it goes up, and like you said, it reached stationary point 0, and then
a gradient is equal to 10. What do you mean by gradient? Slope of the VT graph is acceleration.
Yeah. Yeah.
And here acceleration is G.
So then C would be at which point is the ball at its maximum height? Also point B. So at which point is the ball stationary? It will be B only, no? When it's at its highest point.
Where they have asked. At what?
C.
B only.
At which point is the ball stationary? Also B. Then D. What is the ball's acceleration at point
So
C?
this was B, and here also B. What is the ball's acceleration at point C? That is 10 meter per second square.
Acceleration would be 10 meter per second square. Speed would be 30.
But they have asked for only acceleration.
Then 10 meter per second square. But won't it be because it will be V minus U upon T, right?
Finally, conclusion is
10 meter per second square.
10 meter.
Then what is the ball's acceleration at point A?
So answer became, and at A
will also not be 10 meter per second square.
Minus negative.
Yeah, negative 10 meter per second.
And what is the ball's acceleration at point B? At highest point, speed becomes 0.
But acceleration is still 10 meter per second.
Yeah.
Negative, positive?
Up, positive होगा. At which point does the ball have the same speed as when it was thrown?
When it reaches right back.
Yes, at lowest. This was an intelligent question.
Yes, sir.
What can you conclude from all these 4 graphs?
Slope is acceleration.
Slope of VT graph is acceleration.
And slope of DT graph is speed.
DT matlab position time or distance time. Yeah. Speed.
Yeah.
Take care. And wherever slope is not there, matlab it is constant speed means no acceleration.
So this is constant speed.
Yes. This is free fall. in which they might be comparing the time duration for all
So
four.
four balls with different masses are dropped simultaneously from the highest shown air. From the height shown, air resistance may be ignored. Which ball hits the floor first?
Wait, they are
So
are
T
to be
equals to
compared.
root H upon G.
So basically, we are to compare
The mass doesn't matter.
because H is equal to half GT square is independent of mass.
Yeah.
Mass is irrelevant for this discussion. So that means we have to compare T1, T2, T3, T4. We have to calculate, compare. So you are comparing, okay.
0.316
T1,
for T1, 0.316. 316.
0.3132 seconds. T2 is 0.44.
Third is 0.54.
54 seconds. The longest time duration.
0.63. Longest would be D, so it'll answer A.
You
No,
got-
I got change. Yeah, I got inertia.
Inertia. Inertia is not momentum.
I got change in momentum.